So today we're doing direct variation and inverse variation. I'll separate the videos, so they're two separate videos and it's not one big long video. Especially if we don't finish up the inverse variation, it'll be on the other one. All right, so direct variation is when you have a dependent, y is proportional or varies directly with an independent, meaning as one quantity increases, so does the other. And it's kind of a dependent relationship. Okay, it looks like y equals kx. This should look familiar to you. What is that? Y equals kx. What does it look like? Anybody? Come on, guys. You've seen that before. It's slightly different.
Y equals mx plus b.
Yeah. Doesn't it look like y equals mx plus b?
Yeah.
What's different? K instead of? And what else?
There's no y.
There's no y-intercept. What is the y-intercept here?
0.
0. So in direct variation equations, your y-intercept is always 0. What does it mean on the graph? What does that mean on a graph?
Straight line.
It's a straight line going through what?
The y-axis. Or no, the x-axis.
The origin. It's going through the origin. It's going through 0, remember? So on your graph, you're going to have something that might look like this, and your direct variation equation goes through the y-axis, the origin. Okay? So it's the same. K is like M, only we use K. Back in 7th grade, in Math 7 or Accelerated Math 7, you learned about the constant of proportionality. Do you remember that?
No.
Okay, you should have gotten it in both Math 7 and Accelerated Math 7. You learned about the constant of proportionality. That is your K. In slope-intercept form, it's your M. That is your constant of proportionality. The difference is the K, it just stands for constant of proportionality. M stands for slope. It functions the same way. It still is our rise of a run. Okay? The difference in these two is that y equals kx has no has no b. Now, I asked earlier what this is called, and somebody said it's slope. Another person said it's y-intercept. So I want to clarify. When you, slope is m. Y-intercept is the b. And when you have y equals mx plus b, what do we call this? Slope-intercept. You need to use both words. Do you understand? I don't want you to refer to this equation as slope, as intercept, but it should be called slope-intercept or slope-intercept form, either way. Okay? Now, how it's different is this is plus 0. This is plus a number, right? Does that make sense? Notice the x. What power is it to? It's to the first power. So in direct variation equations or in slope-intercept form, our x is to the first power. So now I'm going to ask you to, and K stands for constant of variation. Sorry, C-O-N-S-T-A-N-T. Just represents, it could be negative, it could be positive. It's the constant of variation. Okay? So now I want to see your thumb up in front of your chest. Everybody put your thumb in front of your chest like this. Not high. I don't want you to show people. I want to see everybody's thumb. Every thumb matters. Every thumb matters, okay? I want to see, I don't see Tony and Isabel. Okay. Down low. Okay, so we're not showing people. This is yes. And when we turn it down, this is no. Yes, no. Yes, no. Okay? So, number 1, y equals 4x. Is this a direct variation equation?
Yeah.
Show me with your thumbs, yes or no. Every thumb matters. I see these rows. These rows, yes, yes. I'm not seeing anything on Chloe. Oh, your jacket's hiding it. You've got this like big collar. And your hair, there we go. Okay. Yes, it is a constant, it is a direct variation equation because there's no b and it's in the form of direct variation. What about the next one right here? Show me with your thumbs, yes or no. Elise, why do you think...
No, it's wrong.
Okay, Fionn, why do you think this is a direct variation equation?
Because there's a constant of 1 to the x, so it's just negative 1x.
Yeah, it can be a negative. So it's like the y equals negative 1x.
Oh, yeah, I was looking at the other one.
Okay? I'm pointing at it with the pointer, right? So this also is a direct variation equation. The next one, y equals 5x squared. Show me with your thumbs. Y equals 5x squared. Okay, Elise, why is this not a direct variation
I
equation?
think because it says y equals kx and it's y equals 5, and the x is squared in this one.
Which one?
And the
What is your reasoning that it's not?
and y, if the formula is y equals kx and there's no square to it.
Correct.
Yeah.
So the reason why it's not is because x is to the second power. In direct variation, x is to the first power. So we do not circle it. What about the next one? Y equals 2/3 x. Everybody show me with your thumbs first. Okay, Gracie, why do you say this is direct variation?
It's direct variation because it's the same formula. You just substitute 2 over 3 for k.
Yeah, our constant of variation is 2/3. Another term for this is constant of proportionality. Do you remember that? Constant of proportionality from last year? Same thing. Okay, next one. Get y alone. Tell me, is this a direct variation equation? Show me with your thumbs. If you got y alone in your head, is this a direct variation equation? Mike, is it a direct variation equation?
I don't think so.
Okay, why?
Because if you get y alone,
What do I have to do to get y alone?
multiply x from both sides,
And then what do I get?
you get y equals 7x, so it would be
So it is because once I get the y alone, I get y equals 7x. 7 is my constant of proportionality, or 7 is my constant of variation. Next one, show me with your thumbs. Actively, okay, Tony, why is it not?
Because x is to the third power.
Good. Next one, y over 3 equals x. Is this a direct variation equation? Show me with your thumbs. Chloe Cross, why are you saying that? Yes,
Because if you get the y alone, then it'd be y equals 3x.
perfect. Okay, and then the last one, y equals the square root of x. Show me with your thumbs. Show me with your thumbs. Julia, your thumb matters too. Every thumb matters, no thumbs left behind. Thank you for cracking a smile. That's my George Bush joke. No child left behind. Okay, this is not no child left behind, no thumbs left behind, you know. All right. Questions? Okay, so now, there's 2 different ways that they can ask us this question. The first is like this, where they give us some values, and they're not going to say, find the k, find the constant of variation. But what they give you in that equation, first of all, they tell me right away, y varies directly with x. So the very first thing I do is write y equals kx. Whenever you see that, you write y equals kx. They don't tell me to find k, but what do? They give me values of x equals 3 and y equals 21. So I'm going to substitute Now what do you think I do? What could I do with that? What do I have the ability to find right now?
Can you divide it?
Divide both sides by? Good, get that k alone, and we have the ability to find the k. Right? But they're not done with that, because that's direction number 1. When y is 3, when x is 3, y is 21. Yes?
You plug it in and you get y equals 7 times 8.
Right, we go back to the same equation, y equals kx. And now they say find the value of y, find this, when x equals 8. Well, we know k is 7. And so what is y?
56.
56. So that's one way they could present this equation. Does that make sense? All right. Can I erase and move on? Oh. Just showing you here. Okay, can I move on? Don't all talk at once.
Yeah.
Thank you. Feedback, please. Okay. Here's a word problem. They're not going to say use direct variation. We say let's first of all, what's my depender here? Is this a dependent relationship?
The amount of cookies you make.
Is the
Dependent.
depender, right?
Yeah.
So that would be our X or our Y? What's the Y? Good. So Y is cookies and X would be flour, right? Now, I'm going to do this when I see as one quantity increases, so does the other. As my flour increases, do my cookies increase? Then I can use a direct variation equation. Y equals kx. Okay? And so now I'm going to substitute. I've got 5 cups to 65 cookies. So if I have put 65 here, I have k times 5. Now what? Divide by 5. And k is equal to 13. What can we do with that? Yep. Nope. What kind of close, but you're skipping a step. No, don't tell me an action. I'm going to write the equation. You're too far ahead. Go. Yes.
Y equals 13 times 7.
Or not, you're going just a step too far. Just use what we have. Y equals kx. I can write the actual equation, which is y equals 13x, which would work for any amount of cups. Any amount of cups. And now it says we're going to put 7 cups in. Y equals. So you're all right in what you were saying. I just wanted you to realize that this is actually the equation for any cups of flour to cookies. Does that make sense? I'm going to take that and I'm substituting it in. Okay, questions? Y equals, so y equals 13 times 7 is 91, and 91 stands for cookies. What does this look like to you? What other kind? How would anybody have solved this any different? Yes.
I would just multiply 13 by 2 and divide it by 65.
Go.
You could use a proportion.
A proportion. Remember that? In 7th grade, they did cups to cookies. And then they set it up. You know, I have 5 cups to 65 cookies. What happens when I have 7 cups to X cookies? Right? We could do 65 times 7 times equals 5X. Does that make sense? Okay. I always have kids make sure and do this so that they set up the proportion correctly. So these are just proportional quantities. Anything as a proportion, once you figure out what the depender is, you can set it up as a y equals kx, a direct variation equation. Does that make sense? Okay, so here is yet another way. I gotta get rid of Okay, let's graph it. Let's see what it looks like. What did we say it's going to look like? What did we say it's going to look like on the graph? Knowing that there's no b plus b. Eitan. It's going to be a line through the origin. So it starts at 0. Now I would just do my m plus my b, even though it's not my m and my b. It's my k, which is my m, and my b equals 0, right? So I'm going to start here, and my m is 1 over 2. Remember, that's a rise over run. So I'm rising 1, running 2. Rising 1, running 2. I could go negative 1, negative 2. Negative 1, negative 2. Okay, questions? I could have set up a table too, since there's no b. I probably would not have chosen these numbers here. I would have chosen numbers like 2, 0, negative 2, 0, and positive 2, because I wouldn't have graphed these in between points. That's eyeballing it too much. Does that make sense? So we could have set up a table. All right. Now the next way they could present this to us. What are they asking? They said y varies directly with x. So right away, every time I see that, we have to write
Y equals kx.
Okay? But this time it says use the given values to write an equation. Write an equation. If I do this, 20 equals k times 5. Is this the equation they want? Does this talk about the direct variation equation for all problems in this sequence?
No.
No. So what would I need to do?
Divide both sides by 5.
Dividing by 5. And then we get k equals 4. What do I do with that 4? Right, we put it into y equals kx, and y equals 4x, and this is my answer. Does that make sense? Now, do you understand the difference? Do you understand the difference of this equation versus the other equation?
Yeah.
Let me have you guys practice on this next one, number 2. And then I'll go back and compare it to the directions for the other one as well. Okay, pause the recording. You guys do number 2. All right, so I'm going to write the equation, y equals kx. What would I do next? What do I do next? Go, Brianne.
You would substitute the y with 18
Equals.
equals k times 48.
And then?
You would divide both sides by 48.
And we get, it simplifies to?
It simplifies to 3/8.
Good. And so what would the equation be? The direct variation equation?
The direct y equals 3/8 x.
Perfect. Okay, so very quickly, notice here it says write an equation that describes y in terms of x. That's when you write it like this. Y equals 3/8 x. A direct variation equation is written like y equals 3/8 x. Versus, okay, the variable y varies directly with x. Notice it doesn't say write the equation, okay? They give you data, you use it, you find your k. Did they ever say find k? It's implied. You use that equation to then find your data when given x. Do you understand the difference in the way they're done? Notice in word problems, as one quantity increases in a direct variation, the other increases. As one, this rises 1, it runs a positive 2. Okay. As the cups of flour increase, so does the number of cookies you get. So now let's go to some word problems. Okay, let's look at one in particular. This data is showing a relationship between the forefinger and the pinky. They're saying that this is proportional, right? You're not going to have a forefinger that's like a foot long and a pinky that's an inch, right? They're saying there's a relationship. So if I use my direct variation equation, they're proportional, y equals kx, right? If I get the k alone, what would I do to get k alone?
You divide
Divide both sides by x. So isn't my constant of variation or constant of proportionality equal to y over x? Right?
Yeah.
So I really can take 6.5 divided by this, 8 divided by this, 9 divided by 7 and 5/10, 9 and 8/10, and divided by 8 and 1/10. Does that make sense? Let's see what we get. Okay, so can we estimate this to be about 1 and 2/10? So what would my constant of my direct variation equation be? If my k is about 1 and 2/10, what would it be? Anybody? Direct variation equation, what would it be for any pinky and?
Y equals 0.2 or
Not-
1.2x.
Yep, y equals about 1.2x. Okay, questions? Now notice, as the forefinger gets bigger, what happens to as the pinky gets bigger, what happens to the forefinger?
It's bigger.
Yeah. Both quantities are increasing. So which of these is a direct variation equation? Money collected and the hours worked. So if I work a lot of hours, does my money go up?
Yeah.
Both quantities increase, so is it direct variation?
Yes.
Yes. Okay, distance traveled and the speed of the car. The faster I go, do I travel more distance?
Yes.
Yep. I cover. Who knows what that formula would be?
D equals RT.
Yeah, it's a direct variation equation. You've been dealing with this. Nobody's told you the actual name of it. Do you understand? And what the K in this situation is what?
The time.
Time. We have the speed and we know the distance, but the T. What about area of a circle? What's the formula?
Yeah.
What is it? A equals pi r squared. Is that a direct variation equation?
No,
Why?
because the r is squared.
Yep. So it's not. What about circumference? Who has the formula? You should know these guys.
3/4.
What is the circumference formula? C equals
Pi.
1/5.
it's not 1/2 pi. Oh my gosh.
Like,
1/2 R.
It's not 1/2.
3/4.
Okay, stop just throwing out words. We're recording.
it's 2 pi r squared.
Okay, or pi times diameter. Okay? Pi times diameter. Is that a direct variation equation?
Yeah.
Yes. What about the age of Sam? Sam and his brother, who's 5 years older, younger. So what would that equation be? Sam equals
K minus 5.
okay. Would that be a direct variation equation? No. Just because it has the -5? No. Okay, or +5. Brother plus 5 equals Sam's age. Does that make sense? All right, so this is direct variation. Questions? Okay, I'm going to stop the recording and we will go on to the next one for tomorrow night. Tonight you are doing page 559, 1 through 23 odd. All. Sorry.